Hello and welcome to another video where I'm going to talk about C++. Ironically, on today's code, I'm starting with a C code. So let's take a look. I have a structure here that has a pointer inside it. The pointer will point to a piece of memory. So this is a resource that needs to be handled. This is common in C code that you have structures that will handle some kind of resource. Here is memory. It could be file, it could be a log. These resources will require initialization and deinitialization. So often the solution for that is you will write an init function and the deinit function, which will take the responsibility of initializing your structure with proper values and deinitializing it when done. This kind of same pattern also appears on C++ code that uses some kind of library. Then the library uses C interfaces for ABI stability. And you will see these kind of functions libinit and libdeinit. The libinit simply allocates memory for my instance, initializes my instance, and passes it to me. And when I'm done with it, I will pass it back to the deinit function, and deinit function will deinitialize and deallocate the memory. So what has happened here in use cases like this, for example, let's see this use case that I have prepared here is that you have allocation of memory in the variables at the beginning of your scope. These allocations are often on stack. This could be on registers for after optimizations, but let's assume here that these are on stack. So I have allocation of my memory separately here in my variables. Then I'm initializing that memory with my call to init function here. And after I have initialized it, I will be able to use it. So this is actually, as you can see, prone to many bugs. I could be using my instance without actually initializing it, or I may forget to deinitialize it, for example, like this. Then I'm leaking resources, and that is probably not good. And there is a special case here that you can see. Sometimes you will have lazy initialization. That is, I'm going to decide when I need to initialize it and initialize my resource, my memory, when I need to initialize my memory. But the allocation of the memory is done previously. So there's a time difference between where I allocate my memory and where I initialize my memory. But this does not happen in the common case. The common case would be that I will allocate my memory and initialize it immediately and use it directly after. So in C++, the thing is that we want to kind of minimize this boilerplate that I have to do. I have to declare this variable here for memory, initialize it, and don't forget to deinitialize it, and all this stuff like that. This is done using constructors and destructors. So constructors and destructors are the thing that is called RAI. Will provide us the concept that is called RAI. Resource acquisition is initialization. So here on constructor, I'm initializing, and while I'm initializing, I am acquiring some resource. So this is my memory acquisition, and I'm initializing my pointer there. So on this line of code, I'm allocating memory and initializing immediately the common case that is spoke that happens on C. And the destructor will be called at the end of the scope, and that will deinitialize my memory, and then the allocation will be as well released. So this also provides this feature that I can kind of limit the lifetime of my instance here and when the instance is going to be initialized and when it is going to be deinitialized. However, still my allocation and initialization is coupled together. So to get that lazy initialization, this is not what will provide me the utility for it. But there are solutions like stud optional here. My state optional here will allocate enough space for my structure here, my instance here. It will be able to hold my instance, but it will not initialize my instance. And whenever I feel the need to actually initialize it manually, I will be able to call in place here. So I'm calling in place here. This code pretty much does what the old code does. So let's stick here for a bit and see what usually happens in real code. The code that I usually see people write init member functions and the init member functions that does the initialization and deinitialization because they can actually call these manually. You can't call constructor manually that easily, or the destructor manually. We will see how you can call those, but that is not the common case. That's not what is expected of a normal C++ programmer to know how to directly call the constructor or directly call the destructor. That is something that a support library developer will have to know to provide utilities like optional. So optional will allow you to actually lazy construct and lazy destruct stuff or early destruct stuff. For example, here my reset function call to reset will deinitialize any instance that lives inside my second instance. If the instance is not there, it will not be destructed. So this also avoids the kind of bug that comes with init and deinit functions. I will never forget to deinitialize, destruct my instance here. My instance will be destructed when the variable runs out of scope anyways. However, this comes at a cost. We have a boolean inside our optional that indicates whether the optional is available, it has an instance or not. And that is like sometimes it will be at most, in most cases, like 8 bytes of extra memory that you will have to pay for. Also, the reset will also check that if it will have an if statement to check that boolean, and that will cost you some performance. Same as in the case of destruction. The destruction, the same boolean check will be happening, and you will lose a bit of performance there. So my optional here, my second instance, comes at a cost, but it avoids many of the bugs that we often encounter. However, there are possible ways to do this without any performance penalty. Also, it is important to note that this std optional is provided on C++17 with the standard library, and before that you will have to use boost optional, which kind of has the same kind of semantic, but it is not the standard library. So that's also not that good either. So the other option you have is to call the constructor and destructor manually. So let's say I'm kind of allocating some memory here with malloc, reinterprecasting it to the type of pointer that I need to, and then I'm calling here the placement new. What placement new does is it takes the memory that you want to construct something inside it and the type that you want to construct, and will construct this type inside this memory, and will return a pointer that you will have to use. You cannot use the old pointer here. So you will have to use the new pointer. However, on C++17, you can use std and use the old pointer rather than the new pointer. So that is one option that you have. However, this option is not perfect. We're allocated on heap, not on stack, whereas on our C code, these variables probably will live in stack. So to do that, you could use C++11 feature that is called std line storage. Just one note that I'm going into some kind of advanced features of C++. This is not something that the daily user of the C++ will have to do in his daily usages. You will most likely often see the common case, use the common case, not need to do optional or stuff similar to that. But in case you need it, you can probably, in most of the cases, just use the optional and avoid. And you will be able to pay the extra cost that comes with it, but you will be safe. And in some rare cases where you're developing some kind of support library and stuff like that, you will probably have to write this kind of advanced code, which I hope you never have to. So yeah, you could use state aligned storage here for your storage, for your memory, and using that memory that will probably live on stack, you can pass that memory to new, to placement new, then placement new will simply construct your type on that memory. Placement new does not allocate any memory. And then since you have manually constructed, you will have to destruct it manually as well, which calling the destructor will do. On C++ 17 and later, calling destructor is guaranteed by the standard to call the destructor immediately. However, before that, I believe the standard did not mandate calling the destructor immediately. However, every implementation did. So these are kind of three ways of doing what C++ code does, C code does. Please avoid writing deinit and init functions in your structures. Use simple uh, constructor and destructor. And if you find yourself using optional all the time, you probably have a design issue in somewhere. So it is better to fix the underlying design issue and avoid not using the common case, because the common case often is enough. And please avoid going into this kind of code. This is very advanced code that is really prone to bugs. It can easily go produce undefined behavior, and you will probably have to read about strict aliasing rules and stuff like that, which are advanced topics on C++. So I would advise against using this kind of code. Anyways, I believe that's all for today, and thank you for watching. Make sure to hit like if you like this video, subscribe for more videos like this. Bye.